Do you remember when we talked about exponents? Okay, if we were given this problem like here, x to the fourth times x to the fifth, what did we do with the exponents if we were multiplying like bases? You add them, so you would get x to the ninth. Okay, what about if we had x squared to the third power? What would you do with those exponents? Yeah, it's a power to a power, so we would multiply those two, so we would get x to the sixth, right? I'm going to need you to remember these two things today, okay? Now, well, these are exponential rules, right? Those are, when we're talking about exponential rules, how do we relate exponents and logarithms again? How are they related? Say it. Well, they're friends, yes, they're right, okay? But they are inverses of each other as well. You remember that? When things are inverses, a lot of the similar kind of rules apply. So if we'll remember these exponent rules, today when we're talking about some logarithm stuff, we're going to be fine. Okay? So here's the first thing I want to talk to you about. Expanding a logarithm. Okay? If we're expanding a logarithm and I say log base 4 of 3x, that's what the problem is going to look like if you're expanding a logarithm. What? Logarithm? Yeah, it's just log. Like a tree you cut down and get a log. Okay? Expanding a logarithm. Okay. This is what the problem looks like. When we're expanding a log, however many terms are inside that log is actually how many times I'm going to write the word log. How many times am I going to write the word log this time? How many terms are inside the log? 2, right? A 3 and an x. So I'm going to write log base 4 of 3 and log base 4 of x. That makes sense? Now, something's missing, isn't it? I left a space for it. If I'm multiplying inside the log, how do I relate those out here? Yeah. Because I was multiplying the like bases right here, what did I do with the exponents? I add. If I'm multiplying inside the log and I expand, what do I do with them? Add. See how that's kind of related? Yeah, okay. So let's try this one. Log base 3 of 7xy. How are we going to expand that log? What's it going to look like if we expand it? Log base 3 of 7 plus log base 3 of x plus log base 3 of y. Done. Now, today is one of those days where I have to show you and teach you how to do 2 things, well, 3 things if you want to get technical, so that tomorrow we can use it. Okay? So today we're just learning how, tomorrow we're going to use it. Is that fair? Okay. I just didn't want to try to cram too many things at one time. You don't like that and I don't like that. Okay? So, let's do this one. Let me see if I can let you figure this one out on your own. Log base 5 of 4 over x. Anybody have any guesses? Oh, why would you subtract? Mm-hmm. Exactly. So what would it look like? Perfect. It's absolutely right. Very good. Anybody have any questions about that? What exponential rule would match up with that? Like x to the 7th over x to the 5th? What would I get as an answer? X to the second. Because when I'm dividing like bases, I subtract the exponent. Does that make sense? Okay. Then what they're going to do is they're going to put all this stuff together. Log base 2 of 5x over y. What do you think? Log base 2 of 5. Log base 2 of x minus log base 2 of y. Oh, that's great. Good teamwork. So what about this one? Why do I keep trying to use that marker when it doesn't work anymore? Log base 6 of 3x over y z. What do you think? Make a guess. So this is almost correct. It could be. Couldn't be plus or minus. There's two ways that we could do this. The first way we could do this is like this. But the other way we could do it is exactly what you said, make that a minus without, you wouldn't have to have the parentheses there. Does that make sense? Either way is correct. Neither one is more correct than the other. Okay? What are you doing? Oh, the Macarena. Oh, okay, that makes sense to do an algebra class in the middle of a lesson. Oh my goodness. So now let's do something new. Okay? Log, and I'll make it an easy new one. How about that? Log base 7 of x squared. Now, does that look like I can do anything to it? How many terms are there? Just the one, right? So it looks like it should just be exactly what it is itself. But I want you to remember this exponential rule that we talked about a minute ago. When I have a power being raised to a power, what do I do with those two numbers? I multiply them. Okay? What is different about this than anything we've done already? You don't notice anything different? Oh, it's squared. It has an exponent inside the log, right? We don't have exponents inside of logs. Okay? This exponent comes down in front like a multiplier. 2 log base 7 of x. That's a 7. It's supposed to be a 7. Got it? That would be the answer, yeah. So what if we had log base 6 of 3x squared over 2y to the 5th? What would we do then? Where did you get the 10? We'll start here, first of all. Log base 6 of 3. Then what? Plus, what's going to happen to this 2? 2 log base 6 of x, very good, minus well, we already used the 2, right? We already did the 2 right here. So 5 log base 6 of y. Now, notice what I did in these two problems right here. I wrote it both ways that we talked about, right? This way we had minus and then everything on the bottom, and that's a plus because everything on the bottom is being multiplied, right? But with the parentheses, aren't they both subtracting? So that's what I did here. I did both subtracting right here. Okay? Let's see. What about this? Log base 3 of the square root of x. Well, that's another thing that looks like it's already as low as it can go because there's only one term, right? But isn't there a way we can write the square root of x as x to some exponent? What is it? Well, I am square rooting it. How do I rewrite it using exponential exponents? That doesn't make any sense. Fractional exponents. Half. So x to the 1/2, right? Remember, those are the same thing? So how would I rewrite that then? Good. Done. So that's called expanding a logarithm. How comfortable do you feel with expanding a logarithm? Pretty good? Okay. So the other thing I have to show you, and that was really two things for the record, because that and then the whole multiplier thing that we did right here, I just put that in with expanding. Okay. So the last thing I have to show you condensing a logarithm. How many times did I write the word log when I was expanding a logarithm? Every time, as many terms as there were, right? Well, when we're condensing a logarithm, the problem is going to look like this. Uh-oh, I forgot something. Sorry. Okay, can I just start again? That was bad. I'm sorry. This is what I wanted to write. Sorry about that. So how many times is log written? 3 times. When I'm condensing a log, this is the problem, okay? When I'm condensing a log, how many times am I going to write log? Once. Now earlier they were like, yeah, but these don't have a base. And then I was like, oh, good. That makes me happy that you remember that. It's not written, so it is a 10, right? It's the common log. It's the understood base of 10. Okay. So what do you think I'm going to do with all these things? I'm going to go backwards, right? From what I just did with all this expanding stuff, I'm just going to go backwards. These were multiplied right here, so when I expanded them, I added them. So if it's already like this and it wants me to condense and they're added, what am I going to do with them over here? Multiply them. So 9 times what? Yeah, what happens to this multiplier right here? That becomes an exponent. So that's 2 to the 3rd. And then what? Times y, right? Now, there's some simplification that needs to happen here, isn't there? First of all, what is 2 to the 3rd? 8. So this is an 8. Then what else do we have to do? 9 times 8. What is 9 times 8? So log of 72y. Done. What about this? Log base 2 of x minus log base 2 of 9. What do you think?
Ray, I have a question.
Please ask me.
Okay, on the first one,
Mm-hmm.
you said that the bases are going to be 10.
The bases are 10.
Okay,
So on my answer, the base was 10, right?
so on this next one, we don't deal with the bases.
Yeah, I don't. Whatever the base was, that's the same base that I'm going to write for my answer.
So we don't mess with them.
Nope. We do not mess with them.
What if there's
Good point. Ooh, that's a very good question. What if there's two different bases? Two possibilities. Can you combine two different bases? No. So you just leave it as it is. Or you ask me because I might have mistyped it. Or you check your paper because you might have miswritten it. Does that make sense? Okay. But if it's typed in the book, chances are it won't be two different bases. If it's a worksheet that I've written, ask me because I might have mistyped it. Or if it's something you have written from the book, check your work because you might have miswritten it. If that's a word. Miswritten? I don't know. Okay. You know what I mean though, right? Okay. So log base 2 of what? X over 9. Done. Wait, is it done? Is there any simplifying I can do? No. We're good. All right, let's try this one. Log base 3 of 7 plus log base 3 of x plus 4 log base 3 of y minus 6 log base 3 of z equals. What do I write first as my answer? Log base 3. Get that down, right? Okay, so start the answer right here. 7. All right, I got the 7 from here. What do I get from here? The x. What do I get from here? Y to the 4th. What do I get from here? And does it go right here? O divided by z to the 6th. Now, I want you to look carefully because this has been a problem in the past and I'm not going to let it be a problem right now. And the best part is neither are you. You're not going to let it be a problem. Okay? When I subtracted, in the problem, when it was subtracting, I knew that that was divide, right? Do you notice where I put the division line? Right there. I didn't put it like right here. It's just inside the logarithm. We're not dividing the logarithm by 6z, or z to the 6th. I'm dividing what's in the argument already by z to the 6th. You okay? So write log base 3 and then you don't even mess with that anymore. Everything else is in the argument. Does that make sense? Okay. I mean, I could do a couple more examples for you of condensing. It's just they would have to get longer and things like that because that's kind of just how it is. Okay? Let me try one more. Okay. Do I want to do that? No, I don't even really want to do that. Then, oh yeah, I need to do one more. Okay. Let's see. Let's do 1/2 log base 3 of x plus log base 3 of y plus 4 log base 3 of z. What do you think about this? How many times do I write it? So log base 3. We're going to ignore the 1/2 for a second. Okay? Ignore the 1/2 for a second. What do I get on the inside of here? X times y times z to the 4th. Okay? Now, what happens to this 1/2? It turns into a exponent, right? And it's an exponent of that whole thing. But what does it mean to raise something to the 1/2 power? So log base 3 of the square root of x, y, z to the 4th. Didn't that look messy? Did it turn out to be? No. Questions? Pretty easy, condensing and expanding. Okay, so the first section of your homework, 13 through 20, is expanding. The 23 through 30 is condensing. Ask me. Yes, it is. I did not do a good job drawing the square root to make sure that you knew it was inside. Thank you for asking. Okay, see how much of this you can get done before you leave.